Okay, so let's go with mechanics. It has the highest concentration of mass, no repeating topics, and it builds nicely into electricity and magnetism later. The first topic is center of mass, definition, derivation, and numerical. It's the easiest high frequency topic, appears in 4 to 5 out of 7 papers, and it's genuinely simple once explained right. Good confidence builder to start your recording with. Okay, let's start from the basics and build up. Step 1, what is center of mass? Intuition first. Okay, so imagine you are holding a pencil horizontally on one finger. There's exactly one point where it balances perfectly without tipping over. That point is the center of mass. Let's say this is the pencil and this is how we are like balancing it. Okay, so simple definition, center of mass is the point where we can imagine all the mass of an object is concentrated for the purpose of studying its motion. Think of it like this, instead of tracking every single atom in a body, physics says just track this one point and it will behave as if the whole mass is sitting there. Real life example, when you throw a hammer spinning through the air, every part of it moves in a weird curvy path except one point, the center of mass, which moves in a perfectly smooth curve just like a thrown ball. Okay, so it doesn't move, that point, I mean, goes in a straight line. I don't know. Step 2, the formula. Two particles first, simplest case. Imagine two masses on a straight line like a seesaw. Mass 1 at position x1 and mass 2 at position x2. Then the center of mass position is m1x1 plus m2x2 divided by m1 plus m2. Why this formula makes sense intuition? Let's see. It's basically a weighted average of positions. Heavier mass pulls the center of mass closer to itself. If m1 is equal to m2, the center of mass sits exactly in the middle. Makes sense, like a symmetric seesaw balancing at the center. Quick sanity check example. If m1 is 1 kg and x1 is 0, m2 is 1 kg and x2 is 10, then okay, so right in the middle makes sense. Does this part feel clear so far? Just explain the formula further. Let's see. Okay, breaking down the formula piece by piece, the numerical m1x1 plus m2x2. Each term is mass into position. This is called a moment. Mass into position is called a moment. Think of it as how much pull does this mass have and how far away is it pulling from. Bigger mass, bigger pull. Farther position, bigger pull. Multiply them together to get total pull. The denominator m1 plus m2, this is just the total mass of the system. We divide by total mass to normalize, basically converting total pull into an actual average position. Why divide it all? Here's the intuition. Imagine you are averaging test scores, but some test counts more. Weighted average. Like if test A is worth 2 times more than test B, then average would be 2 times test A score and plus 1 times test B score. 2 plus 1. Why 2 plus 1 actually? Divided by 2 plus 1. अभी मुझे समझ नहीं आया why this 2 plus 1, why not just like 2, because there are only two test scores. Center of mass is exactly this idea, except weight of each score equals mass of the particle and score equals position of the particle. So XCM is literally mass weighted average position of all particles. Testing your intuition, but if one mass is much bigger, okay, then what? See that the center of mass is at x equals 1, very close to the heavy mass. Not in the middle. This matches intuition. Heavier mass dominates the pulse and balance to point towards itself. Okay. But why divide by total mass plus. Great question. Let's go even more basic. Think about a normal non-weighted average first. If you have test scores 4 and 10, the average is 7. Why divide by 2? Because there are two numbers and dividing by the count of numbers is literally definition of average. It spreads the total evenly. Now weighted average is the same idea but each number doesn't count equally. Say test A score 10 is worth 2 credits and test B score 4 is worth 1 credit. Total credits equals 3. Instead of adding row scores, we first stretch each score by how many credits it's worth. So 2 times 10 plus 1 times 4 equals 20 plus 4, 24. This 24 is not a real average yet. It's inflated because we duplicated test A scores twice as if it happened 2 times. To get back to a real honest average, we must divide by how many total credits we stretched it by. I don't know what credits are. Mm-hmm. Don't use credits, please. Let's dig into why, not just accept it. Reason one, unit force us to divide. Units force us to divide. Look at just the numerator. Units is kg times meter, but we want an answer in meters, a position, not kg times meter. So we must divide by something with units of kg to cancel it out. So total mass is exactly that. Okay, without dividing, the answer wouldn't even be a valid position. It'd be some meaningless kg times meter quantity. Dividing by total mass is what converts it back into a place on the ruler. Reason 2, the deeper reason, center of mass is defined as the balance point. Here is the real definition from the scratch. Center of mass is the point where if you measure distance from it, all the pulse from each side cancels out to zero. A center of mass is the point where if you measure distance from it, all the pulse from each side cancel out to zero. Mathematically, this means m1 x1 minus xcm plus m2 times mx1 minus whatever mass times distance from center summed equals 0, like a perfectly balanced seesaw. Okay, now let's just solve this for xcm, center of mass, and see what falls out. Okay, so there it is. You can see the calculation. So there it is. The division by total mass isn't random rule someone made up. It falls out naturally from demanding this point must be perfectly balanced point. The m1 plus m2 in the denominator appears simply because we moved it algebraically from the other side. Seeing it derived like this makes the y divide part click. Okay, finally. Awesome. Glad that clicked. Step 3 now extend to many particles, not just two. Same idea, just more items. For n particles, it's m1x1 plus m2x2 plus m3x3 up to m1x mnxn, basically mixi, summation of mixi divided by m1. plus m2 plus m3 summation of mi whatever. What is this I? Anyways, it's simple, nothing new conceptually. Still, oh, wait. Okay, so nothing new conceptually. Still a weighted average, just summed over however many masses you have. Nothing new conceptually, still a weighted average is summed over however many masses you have. The sigma symbol just means add them up. And for a full 2D system, points have both x and y coordinates. You just do this separately for x and y. Okay, so that was one dimensional and this is two dimensional के लिए बस separately करना है. That's it. No new logic. Just apply the same weighted average idea to each coordinate independently. Now let's do your actual exam numerical. This is the exact one that repeats on 4 out of 7 papers. Three particles of masses 3g, 5g and 2g at a given coordinate points. Since you didn't paste the exact coordinates from your question bank, can you give me the actual position like this? So we solve the exact version that shows up in your papers. Wait, let me bring the PYQs. Okay, so great research. This is exactly the right way to prioritize. Let's lock in the plan. Priority order, center of mass, numerical, repeat, stop priority, short definition, two particle derivation, hollow. Okay, so let's solve the numerical from absolute zero step by step. The question: three particles at three particles 3g at 1 0 minus 1 5g. What is this 5g? 5 gram? What? 5g at this and 2g at this. Find coordinates of the center of mass. Extend the formula to 3D. Step 1 is extend the formula to 3D. We already know this since points now have x, y and z coordinates. We just repeat the same formula three times, once for x, once for y, once for z. No new concept, just more bookkeeping. Organize the data. This prevents silly mistakes. Okay, particle 1 2 3 and then mass is and the coordinates. Total mass is 3 plus 5 plus 2 10. Calculate xcm. Okay, 1 minus 2 and 3, 1 minus 2 and 3, 0 1 and minus 1, 0 1 and minus. Okay, fine, fine, fine. Perfect. Okay, so final answer is this: minus 0.1, 0.3 and 1.4. That's it. Every time this exact question repeats, same number, same method, same answer, free marks. Does this calculation make sense step by step? And want to also do the position vector part quickly. It's literally the same answer, just written differently since it showed up once too. I got it. Chalo. Nice. One topic down. Quick bonus since it's basically free marks. Position vectors of CM is literally the same number. What position vector of CM is literally just the same number, just written in vector form. Okay, so okay, बस I J और K लगाना है. That's it. That's it. This is simple. That's it. No new calculation. Just repackaging the same answer with I, J, and K, however they are pronounced, instead of separate coordinates. As you guessed, velocity of CM from Feb 2022 needs velocity data that isn't given in this version of the question, likely a typo or incomplete transcription in your source. So the original question had extra data. Don't worry about that part. So center of mass numerical done, exam ready. Want to move to the next topic, either definition of center of mass. ये तो हो गया था ना. Constraints plus types. Are we done with center of mass topic. Almost one simple piece left. Your call on whether to do it now or skip. Want to knock out the definition now or move straight to the next quick topic? Let's complete this. Okay, so definition of center of mass exam ready short answer. This is the part that shows up as quick 2 to 3 marks sub question. Here's the clean version. You can write directly in an exam. Center of mass of a system of particle is that point at which the entire mass of the system is imagined to be concentrated and which moves as if all the external forces were acting directly on it. Mathematically, for a system of particles, it is given by this. Okay, and breaking down why examiners want this exact wording point where mass is imagined to be concentrated shows you understand the concept, moves as if all the external forces act on it, shows you understand why it's useful. This is deeper physics reason, it simplifies motion analysis of complex bodies. The formula shows you can back it with maths. That's the whole definition, nothing more needed for 2 to 3 marks. Subpart center of mass fully computed position vector definition derivation is left. Skip low priority one repeat only. One topic fully checked off from your list. Um, let's do the derivation tool. If it's difficult, we'll skip. Is it only appeared once in the Okay, so two particles, center of mass derivation. Let's build this from scratch. Deep breathe, deep breath. This is just algebra, nothing scary. Set up. Picture the situation. Two particles on a straight line, m1 at position x1 and m2 at position x2. We want to define and derive where their center of mass sits. What defines center of mass? The core idea. Center of mass is point x cm, where if you measure how far each mass is from it, the turning effect moment from both sides exactly cancels out like a perfectly balanced seesaw. Mathematically, this balance condition is written as this. ये तो हो गया था ना. In plain words, mass 1 times its distance from the center plus mass 2 times its distance from the center equals 0. They cancel each other out. One is positive distance, other is negative, since one's on the left and one's on the right. Just solve this equation for xem pure algebra. We already did it actually. Expand the bracket, then group xem terms together, factor out xem on the right side, divide both by m1 plus m2 whatever. So step 3, that's it for a full exam answer. Wrap it with words, full exam style answered, structured. Write the plain language definition, same one from before. Draw a simple diagram, two masses on x-axis with xem marked between them. Write the balance condition equation. Write the balance condition equation. Show the three-line algebra above. Box the final formula. That's the entire derivation. Literally just this one equation rearranged. No integration, no calculus, no tricky steps. Did this feel doable in under 10 minutes or did any specific step? I got it. Thanks. Let's end this now actually. Nice. That's entire center of mass topic fully complete. Numerical position vector definition derivation. Solid first topic to have in your bag before your recording even gets going. Okay. We'll do this later. For now, it's fine. Bye.